Let's clear up one thing right away, because it actually makes this story more interesting. No, T-less. James Webb didn't just see Titan for the first time. It's been quietly studying Saturn's largest moon since late 2022, and the observations it gathered back then already reshaped how scientists understand one of the strangest weather systems in the entire solar system. But in the middle of 2026, something new turned up buried inside Webb's data, something that genuinely doesn't match anything scientists have ever cataloged before on Titan or anywhere else. That's the real story here, and it's stranger than any clickbait headline needs to make it. To understand why Titan deserves this level of attention in the first place, it helps to understand just how genuinely bizarre this moon is compared to almost everything else orbiting the Sun. Titan is the largest moon of Saturn, and it's actually larger than the planet Mercury, making it the second largest moon in the entire solar system behind only Jupiter's moon Ganymede. Unlike most moons, which are airless, frozen rocks with essentially no atmosphere worth studying, Titan is wrapped in a thick, hazy orange-tinted atmosphere made primarily of nitrogen, the same gas that dominates Earth's own air, mixed with a significant concentration of methane. That atmosphere is so dense that surface pressure on Titan actually exceeds Earth's by about 50%, dense enough that, in theory, a human standing on Titan's surface with proper thermal protection wouldn't need a pressurized suit to keep from being crushed. And Titan doesn't just have an atmosphere. It has weather, genuine, complex, cyclical weather in a way no other body in the solar system besides Earth actually does. On Titan, methane plays the same role water plays here at home. It evaporates from lakes and seas, rises into the atmosphere, condenses into clouds, and eventually falls back down as rain, carving river channels and filling enormous lakes and seas across the moon's northern hemisphere, some of them rivaling the scale of North America's Great Lakes in total surface area. It's the only other place we know of in the entire solar system where liquid actively flows, pools, and evaporates across a planetary surface, even though the liquid in question isn't water, but frigid super. Cold liquid methane and ethane sitting at surface temperatures, hovering around negative 290 degrees Fahrenheit. Studying that methane weather cycle in real detail is exactly what brought James Webb to Titan in the first place, working alongside the ground-based Keck Observatory in Hawaii. Starting in November of 2022 and continuing through observations in July of 2023, a team led by researchers at NASA's Goddard Space Flight Center used Webb's extraordinarily sensitive infrared instruments, combined with Keck's ground-based imaging, to track Titan's cloud systems in a level of detail nobody had managed before. What they found genuinely surprised them. For the first time, scientists documented direct evidence of cloud convection in Titan's northern hemisphere, the same region where most of the moon's lakes and seas are concentrated, watching methane clouds actually rise to higher altitudes over the course of just a few days of observation, behaving in ways that closely paralleled how convective storm clouds build and develop here on Earth. Because Titan's northern hemisphere is currently experiencing its summer season, a season that, thanks to Saturn's enormous 29-year orbit around the Sun, lasts roughly 7 Earth years. Researchers believe increased evaporation off the surface lakes during this warmer period is likely fueling the cloud activity they observed. Webb's instruments also picked up something else during those early observations that turned out to matter enormously for understanding Titan's chemistry. A clear detection of a specific carbon-containing molecule within the atmosphere, offering scientists new insight into the complex chain of chemical reactions constantly playing out in Titan's hazy skies, reactions that slowly break down methane and reassemble its components into more complex organic molecules, some of which drift down and accumulate on the moon's surface over time. It's part of why scientists have long found Titan so fascinating from an astrobiology perspective. While nobody seriously expects to find life as we understand it, surviving in temperatures cold enough to freeze methane. Solid, Titan's ongoing organic chemistry offers a genuinely useful natural laboratory for studying the kinds of prebiotic chemical processes that may have played a role in the early chemistry of life here on Earth, billions of years ago. All of that was genuinely exciting. Documented, peer-reviewed science, published through NASA's own science communications channels. But it's what happened more recently, in the summer of 2026, that's actually earned Titan the something is off reputation currently circulating online. This part of the story deserves to be told carefully because it's still very much unfolding in real time. In early July of 2026, a team of researchers uploaded a new study to Archive, the preprint server scientists use to share findings before they've completed the full peer review process required for official publication in a scientific journal. The study focused on a specific, relatively underexplored range of infrared wavelengths in Webb's existing TIDI and Pluto data, wavelengths that hadn't received as much detailed attention in earlier analyses. Buried within that data, the researchers identified something they genuinely couldn't explain. a distinct, previously undocumented absorption line centered around 5.11 micrometers, appearing clearly in the spectra of both Titan and Pluto. Here's why that specific detail matters so much to scientists, even though it might sound like an obscure technical footnote to anyone outside the field. Every chemical element and molecule in the universe absorbs light at very specific, characteristic wavelengths, essentially leaving behind a unique fingerprint in the spectrum of light reflecting off or passing through it. It's exactly how astronomers identify what distant planets, moons, and even entire galaxies are actually made of, without ever needing to physically visit them, by carefully reading which wavelengths of light are missing from the spectrum they observe. When researchers compared this newly identified 5.11 micrometer signal against the full catalog of known gases, ices, and haze particles believed to exist in Titan's atmosphere, running their measurements through detailed radiative transfer models that account for every known compound, the signal simply didn't match anything already on the list. It wasn't residual methane. It wasn't any of the known nitrogen or hydrocarbon compounds already documented in Titan's atmospheric chemistry. It was something else entirely, something without a name yet. What makes this finding even more intriguing is where researchers determined the signal was actually coming from. By comparing the spectrum measured at the center of Titan's visible disk against the spectrum measured near its edges, scientists were able to test whether the mysterious absorption originated in the atmosphere or on the surface itself. If the signal came from gas in the atmosphere, it should have appeared stronger near the edges of the disk, where light passing through to reach Webb's instruments travels through a thicker slice of atmosphere at an angle. Instead, researchers found the opposite pattern, with the signal appearing weaker near the edges and stronger toward the center, a pattern consistent with the absorption originating from Titan's actual surface, rather than from any gas floating in its thick atmospheric haze above it. And then there's the detail that's arguably the strangest piece of this entire puzzle. The exact same unexplained signal turned up in Webb's data for Pluto as well, a distant, icy, dwarf planet that shares remarkably little in common with Titan on the surface. Pluto sits far beyond Titan, orbiting the Sun at a distance more than 7 times greater, with an atmosphere so thin it's barely detectable compared to Titan's dense nitrogen-methane blanket. The two worlds differ enormously in size, composition, temperature, and geological history. Finding the same unidentified chemical signature on both of them, worlds that shouldn't obviously share the same surface chemistry, is exactly the kind of coincidence that makes researchers sit up and take the finding seriously, rather than dismissing it as some kind of instrument artifact or measurement error unique to one specific target. So what could actually be causing it? At this stage, honestly, nobody knows for certain, and that's precisely why the study remains a preprint rather than a confirmed, peer-reviewed discovery. Researchers have floated the possibility that the signal could represent a previously unidentified organic compound, potentially one formed through complexo photochemical reactions happening in extremely cold, low-pressure environments, unlike anything easily replicated in laboratories here on Earth. Given that both Titan and Pluto experience intense, long-term exposure to ultraviolet radiation and cosmic rays interacting with simple molecules like methane and nitrogen, it's plausible that both worlds might independently be producing the same complex molecule through broadly similar, if not identical, chemical pathways, even given their otherwise very different environments. It's important to be honest about where this stands scientifically, rather than let the mystery run further ahead of the actual evidence than it should, a single preprint. Study, however carefully conducted, doesn't constitute a confirmed discovery of a brand new molecule. The next steps, additional observations, independent analysis by other research teams, and eventually formal peer review, will determine whether this signal holds up as genuinely novel chemistry, or whether some more mundane explanation, perhaps an unusual combination of known compounds producing an unexpected combined signature, ultimately accounts for what researchers are seeing. Science works exactly this way, through careful incremental verification rather than single dramatic announcements, even when the initial finding is exciting enough to generate real buzz within the planetary science community. Still, it's genuinely rare for Webb's instruments to turn up a signal that doesn't fit anywhere into existing models, especially one appearing consistently across two very different worlds. Titan and Pluto have each already reshaped our understanding of what's possible in the outer solar system once before. Titan proved that Earth isn't the only place in our solar system with active weather and standing liquid on its surface. Pluto, once dismissed by many as a frozen, geologically dead rock following its 2006 reclassification as a dwarf planet, turned out through NASA's New Horizons flyby in 2015 to have surprisingly active geology, including evidence of relatively recent surface change S. Now, both worlds may be about to teach scientists something new yet again, this time about a chemical compound nobody currently has a name for. For now, the mystery signal sits exactly where good scientific mysteries usually sit at this early stage, Intriguing, unconfirmed, and genuinely unresolved. Researchers will continue digging through Webb's existing archive and likely request additional targeted observations, hoping to gather enough data to either identify the compound definitively or rule out the more mundane explanations first. Whatever the eventual answer turns out, OBE, it's a useful reminder of just how much James Webb continues to find, even in corners of our own solar system that astronomers have already studied for decades, using ground-based telescopes, orbiting spacecraft, and now one of the most sensitive infrared observatories ever built. Sometimes the biggest surprises aren't found by pointing a telescope somewhere entirely new. Sometimes they're found by looking more carefully at wavelengths nobody thought to examine closely enough the first time around. If this story fascinated you, don't forget to like and subscribe for more deep dives into the ongoing discoveries reshaping our understanding of the solar system, one unexplained signal at a time.